Hello everyone, this is Zui PCB, your trusted PCB partner. Today, we'll be introducing how to clean up components and vias in a PCB using CAD. In the PCB editor of CAD, there's a handy tool that can be used to clean up components and vias. Not only can it remove unused components and vias, but it can also clean up redundant overlapping traces. We can take a look at it under the Tools menu select, Clean Traces and Vias to open the tool. Then we can see that its first option is to refill all copper pore areas before and after cleaning, which means it will refill the copper pore to avoid any vias caused by unrefilled copper during your modifications. For example, this via here, if we refill the copper pore, there will be copper in this area, making this via a valid one. Right now, it's only connected on the bottom layer and not on the top layer, so it's considered a invalid via. Next, let's look at the second option, deleting traces that are connected to different nets. What does this mean? This refers to traces that are incorrectly connected. However, since we previously set constraints, incorrect traces can't be connected under our current restrictions. But if there were no constraints, such errors could occur. So in our current situation, this issue won't happen. Now, let's look at the third point. Delete redundant vias. This refers to the kind of unnecessary vias we just discussed. And the fourth one, delete vias that are only connected on a single layer. These two redundant ones, and this one, these are considered redundant. For example, having an extra via on a single trace, or placing a via where it's not needed on a trace, are both considered redundant. For cases like this, where the copper pore only connects on one side, that's considered a via connected on only a single layer. Next, let's move on to merging overlapping traces. What does overlapping traces mean? For example, when we're drawing traces, sometimes someone might accidentally draw the same trace twice. Visually, you can't tell on the circuit, and it doesn't have much of an impact in practice. However, if these situations occur frequently in your circuit, it could affect the reliability of your circuits and lead to unexpected issues. So we should try to remove anything that shouldn't be there. Next, we have deleting traces that are floating at one end. Take this trace, for example, intentionally drew it with one end floating, connecting only one side, while the other is left unconnected. This situation happens often. For example, when drawing a circuit, you reach this point, finish this trace, then might suddenly have something else to do, or someone interrupts you. When you return, you continue drawing, but forget this trace and perhaps start drawing others. Eventually, you might draw another trace from this side, but this original trace never gets deleted. This kind of trace can have a significant impact. On the PCB, this forms an antenna, emitting signals outward and affecting other circuits. So this kind of situation absolutely cannot exist. If it does, it must be deleted. When the circuit is complex, it's very hard to spot these just by visual inspection, so this step is really necessary. Next, delete traces that are completely within a pad. This kind of issue actually doesn't have very big impact. For example, if I draw a trace inside this pad, but it doesn't extend out of the pad and stays within it, it actually won't have much effect on the circuit. Next, let's take a look. There are also some filters over here. The filters are actually there to help us easily delete certain things we want to manage. For example, with vias, sometimes we place several vias side by side to increase connectivity, but these might be detected as redundant. In such cases, you can either clean them up first and then add these vias, or you can use the filter to clean them up and make adjustments this way. And this particular one here, this specific type is primarily for effectively filtering by net. With this comprehensive net filter, as we can clearly see, we can precisely specify to meticulously clean up only a certain designated net domain. And this one is for filtering by net class. Filtering by net class is quite useful because we can limit the filter to a specific type of net class. I think this is pretty good. As we mentioned earlier, if you have the good habit of categorizing each type of net into a net class, then using this feature at this point is really great. We can clean them up one by one according to their net class. Then, as for layers, we currently have just two, the top layer or the bottom layer. And the last one is selected items only. I think this is also quite useful as it allows us to clean up only a specific area. Sometimes I know that certain areas will report errors here, but those errors are actually reasonable. In that case, we can exclude that area and then run a check to see what happens. At this point, it prompts you whether you want to report a copper. Since I want to show you the error, I won't report the copper. I'll keep the VI error. Now you can see, for example, it removes traces inside the pad. And here, the connection can't reach both layers. There are all sorts of situations like this, and we can click to take a look. Look at this trace. This is the one inside the pad, the one I just drew inside the pad. And this is the redundant via. And as I just mentioned, this is a net with only one end, a trace with only one end, still divided by segments. This one is only on one layer because there's no copper port here. Now let's click Update PCB. See that all the places with errors have been deleted for you, which is really great. All right, that's all for today's content. If you enjoyed this video, please subscribe to my channel for more videos. Thank you, everyone.